Freeze an Airbus A330-900 at the instant it leaves the runway. Up to 251 tons pulls downward. Lift bends its 64-metre wing upward. Two engines load their pylons, and cabin pressure pushes the skin outward. Let us take the A330 apart, build it from the skeleton outward, and see how those systems become one flying machine. The 5.26 metre cabin width supports a typical 287 to 303 passenger layout. Beneath it, an A330-900 can accept up to 33 LD3 containers. Remove the interior and the fuselage becomes a semi-monocoque pressure vessel. Its aluminium skin carries load, stringers resist bending, and circular frames preserve the wide-body shape. Floor beams brace the shell and support passengers above and cargo below. Where do the wing loads actually go? The largest concentration of force lies at the aircraft's centre. Front and rear spars, ribs, and upper and lower wing skins form a torsion box, and both wings meet the fuselage through the centre wing box. During flight, the wings lift and bend upward, while the centre wing box carries those loads across the aircraft. The wing is also a fuel tank. The A330-900 can hold up to 139,090 litres. More surprisingly, a trim tank sits in the horizontal tail. In cruise, fuel can move aft to shift the centre of gravity within strict limits, reducing the balancing force and drag demanded from the tail. The flexible wing is designed to absorb changing flight loads. Conditioned air is constantly circulated through the cabin. Behind the cabin walls, insulation helps control temperature and noise. Even the windows are part of the aircraft's strength. Rounded corners stop stress from tearing into the pressurised fuselage, while reinforced frames carry the load around each opening. Rolls-Royce Trent 7000. Its fan is about 2.8 metres across. For roughly every unit of air entering the hot core, 10 pass around it through the bypass duct. Compressors squeeze the core flow, fuel burns and turbines extract energy to drive the compressors and fan. Each engine can produce roughly 72,000 pounds of thrust. With the airframe and wing, this supports cruise around Mach 0.82. and an advertised 251-ton range of about 7,200 nautical miles. But the same aircraft that crosses oceans at cruise speed must eventually turn flight back into weight. On landing, the A330 pours huge energy into just 10 wheels. Its tyres are layered aviation structures, reinforced to survive heavy loads, high rotation speeds, heat, and repeated compression. The A330 is not built as one piece. Its wings come from Britain, major fuselage sections from Germany and France, tail structures from Spain, and the centre wing box from Nantes. They reach Toulouse already threaded with wiring, pipes, ducts and equipment. Assembly jigs align everything on one aircraft's centreline. Joints are closed, systems tested, then the landing gear, tail, pylons, engines and cabin are installed. That is the hidden engineering of the A330. Not one system doing one job, but hundreds of structures constantly trading force, pressure, heat, fuel and motion. Next, we put the composite Boeing 787 under the same X-ray.